Hello and welcome to today's lesson. Thank you for joining us in this particular discussion. We are going to look at a question on probability. And the question reads, the probability of three dart players, Githongo, Mwai, and Kanyoro, hitting the bull's eye in a competition are 0.4, 0.7, and 0.5 respectively. A. Draw a probability diagram to show the possible outcomes. We have the first player, who is Githongo here. We have Githongo hitting. There is also a probability that Githongo will miss the bull's eye. The probability of hitting is 0.4, which translates to 4 out of 10 as a fraction. The probability of him missing is going to be the remaining to make it 10, which is going to be 6 out of 10. So that is Githongo. Then we go to Mwai. So since now we are adding another participant, the total outcomes are going to be 4, and therefore we are going to have Mwai hitting, then Mwai not hitting. Mwai hitting is 0.7, meaning 7 out of 10. The not hitting is going to be 3 out of 10. Again, we are going to have another branch here where Mwai is going to hit, then Mwai is going to miss. Hitting will remain 7 out of 10, then missing is going to remain 3 out of 10. Then we have Kanyoro. We have Kanyoro hitting, then Kanyoro not hitting. Since now we have 3 people, we are going to have a total of 6 outcomes. So Kanyoro hitting is 0.5, which translates to 5 over 10. Then missing is also 5 over 10. We have Kanyoro hitting, Kanyoro not hitting. This one is going to be 5 over 10, 5 over 10 in that order. Then here we also have Kanyoro hitting, Kanyoro not hitting, which is going to be 5 over 10, 5 over 10. Then the last one is where Kanyoro is going to hit, then Kanyoro is going to miss the bull's eye, and this one is going to remain 5 over 10, and this one is 5 over 10. And by so doing, you'd have represented that information on a tree diagram. Next, we are supposed to find the probability that all the 3 hit the bull's eye. So we have to enumerate by saying probability of all hitting the bull's eye. It is going to be equal to the probability of Githongo hitting, Mwai hitting, and also Kanyoro hitting the bull's eye. Since these are independent events, we are going to take the probability of Githongo hitting, we multiply by the probability of Mwai hitting, we multiply by the probability of Kanyoro hitting for us to get the probability of all hitting. In this case, we are going to take the probability of Githongo hitting, which is 4 over 10. We multiply by the probability of Mwai hitting, which is 7 out of 10. Then we multiply by the probability of Kanyoro hitting, which is 5 over 10. And this one is going to be equal to 4 times 7 is 28. 28 times 5 will give us 140. You divide by 10 times 10 times 10 is going to be equal to 1000. And this one is going to be equal to 0 and 0 goes. Or we can take the common factor between 140 and 1000, which is 20. So 140 divided by 20 will give us 7. Divide by 1000 divided by 20 will give us 50. And that is the answer to Roman 1 of part B. We move down to Roman 2. Find the probability that only one of them hit the bull's eye. In this case, we are going to say probability of only one hitting. So in this case, to get the probability of only one hitting, it means if it is Gitongo hitting, the other two will miss. If it is Mwai hitting, the other two will miss. And if it is Kanyoro hitting, the other two will miss. That is to say, we are going to take the probability of if it is Gitongo hitting, Mwai will miss, Kanyoro will miss, or if it is the probability of Mwai hitting now, that is Kanyoro missing, Mwai hitting, but Kanyoro missing, or the probability of we have now Kanyoro hitting, but or we can say systematically Gitongo missing, Mwai missing, but Kanyoro hitting. That is, if one hits, the other two will miss, or if the other one hits, the other two will miss in that particular order. So, proceeding with our working, Gitongo hitting is going to be 4 out of 10. We multiply by the other two missing, which is 3 over 10 for Mwai, times 5 over 10 for Kanyoro, plus, or means addition. If it's Mwai hitting, Gitongo will miss, which is 6 out of 10. We multiply by the other two. Only one of them will hit the bull's eye. It means if Kanyoro hits, the other two will miss, and if Mwai hits, which is 7 over 10, the other two will miss, that is times 5 over 10. Then we add, this time round, if Kanyoro hits, which is 10 over 5, the other two will miss, which is 6 over 10. We multiply by 3 over 10. And now we can move down and do the operations. 4 times 3 will give us 12. 12 times 5 will give us 60 out of 1,000. We add 6 times 7 is 42. 42 times 5 you get 210. Divide by 1,000, that is 10 times 10 times 10. We add 5 times 6 is 30. 30 times 3 you get 90 out of 1,000. And if you add all the numerators, we have 60 plus 210 plus 90, which gives us 360. So if you take 360, you divide by 1,000. This one is going to give us 0.36. Or a 0 and a 0 will go, so that we remain with the 6 out of 100. And the common factor between 36 and 100 is 4. So 36 divided by 4 you get 9. Divide by 100 divided by 4 you get 25. And that is the answer to that particular question. Then the last part of the question that we have is where we have at most one missed the bull's eye. So what do we mean by that? Probability of at most one missing. So what it means is that it is the probability of one or missing. At most, it is what is quoted and below. What is quoted and below is what we mean by the word at most under probability. So if we continue, we can say if one misses with Gitongo, which is 6 out of 10, the other two will actually hit the target. So that is 6 is the one missing. Then the other two, that is Mwai 7 over 10 and the other 5 over 10 will automatically hit. Plus if Mwai misses, which is 3 out of 10, The other two will hit, that is Gitongo 10, 4 over 10, we multiply by 5 over 10. And if, that is plus, if the other one misses, which is Kanyoro 5 over 10, the other two will hit, which is 4 over 10, we multiply by 7 over 10. From here we can do the workings. 36 times 7 times 5 will give us 210 divided by 1000. That is 42 times 5, which is 210. We add 3 times 4, 12 times 5, you get 60 out of 1000, plus 5 times 4 times 7. This one is 20 times 7. This is 140 out of 1000. This is at most one missing. That is one missing. And then all missing, we are going to add the probability of all missing. And all missing will be 6 over 10 times 3 over 10 times 5 over 10. This one is going to be 6 out of 10 for all missing. We multiply by 3 out of 10. Then we multiply by 5 out of 10. And this one is going to be equal to 6 times 3 is 18 times 5, which will give us 90. 90 divided by 1000. And this one is going to be equal to 210 plus 60 plus 140 plus 90, which gives us 500. Everything divided by the LCM, which is 1000. And if you divide 500 divided by 1000, the two zeros will go. 5 goes to itself once, it goes to 5 two times. And the answer to this question is half, or simply 0.5 as a decimal. Thank you for watching and welcome to our channel.